Hello, everybody, and welcome to the Ultimate Health Model Podcast, where we take a deep dive into uncharted waters, talking everything health. Today, I am beyond excited to have Dr. Nathan Bryan on the program. He has a list of credentials a mile long, and he has basically, I wouldn't say the father of nitric oxide, but he is definitely in the mix. From what I remember on my notes here, you are the one that first discovered how nitrate and nitrite from food is beneficial to cardiovascular health. Is that correct?
That's right.
Okay,
That's right.
great. So anyway, I want to start with a really important thing, a statement I found in your book, just to kind of get people's attention. And it's stated in your book from 2010, which I love, by the way, drinking 5 glasses of water a day for men, and I don't remember the age group though, Nathan, of 5 glasses of water a day decreases the rate of heart disease by 36%.
Yeah.
That's astounding. So we can talk more about that, but for our friends listening, I think, wow, hopefully they're going to keep listening now, because that's really, frankly, I don't know anything that can lower heart disease risk by 46%, not even a drug, nothing on the market. So anyway, why don't we get started and talk about how you got into this nitric oxide and your background?
Well, I'm a small town Texas boy, grew up in the country and then went to high school, graduated top of my class of about 112, 113 people, I think. And then I went to the University of Texas. I got a degree in biochemistry and then quickly realized that a bachelor's degree in biochemistry, there wasn't a lot of job opportunities out there. So I realized I had to go back to school for further education. And, several years later, I enrolled at LSU School of Medicine in their PH.D. program in molecular and cellular physiology. And it was I believe it was the late 90s, maybe the year 2000, but a Nobel Prize had just been awarded for the discovery of nitric oxide. So the entire scientific and medical community knew how important recognized the importance of nitric oxide. And fortunately, we were very fortunate to have Lou Ignarro, who just one of the scientists who won the Nobel Prize, come and speak before our student body and had a chance to have a conversation with him. And he described this, what he called the miracle molecule of nitric oxide and how important it was, but there were still so many unexplained mechanisms of how the human body makes this gaseous molecule, where it goes, what it does, what it becomes, how it signals. And so that really sparked my interest. So that started my journey in nitric oxide back in 2000. Now, 24 years later, I've spent my entire adult career studying how the human body produces nitric oxide, what goes wrong in people that can't make it, and how do we restore the function and production of this molecule.
Nice. Yeah. I've been studying health for myself for 10 years, 15 years, and I am a certified health coach. And I learned about nitric oxide, I think from you, actually, from watching your videos. I think I knew a little bit about it from some other things, but nitric oxide, I believe, and I think this is correct, is you're talking about a miracle molecule, is a signaling molecule. And we can talk about this also later, but it signals everything in the body, from opening the blood vessels to gut motility to brain function to everything, I'd assume. So it's just basically it's the way the cells communicate, almost like a cell phone, right? So this is how cells communicate with nitric oxide. I will probably also the LDL particles and cholesterol and all these things, they probably communicate with nitric oxide too. But anyway, I just thought, yeah, this is really, it's a miracle. So what do people need to know about how do you make nitric oxide if you don't have enough nitric oxide? Let's have our go there with our listening friends.
Yeah. Well, in 1992, Science Magazine declared nitric oxide the molecule of the year. And so in 1998, people referred to it as a miracle molecule. But, miracles are things that happen that have no explanation. So nitric oxide today is not a miracle. We have a clear understanding of how nitric oxide is produced, when it's produced, and then what it does. And there's a clear mechanism of action that explains most every biological action of nitric oxide. So I don't refer to it as a miracle molecule anymore, because everything that it does can be explained scientifically and even translate that into clinical medicine. But you mentioned it's a gas, and it's one of the few gaseous signaling molecules produced in the body. So it really created a new paradigm for cellular communication. Because prior to that, it was always kind of this lock and key type signaling that activated receptors on cells and then induced some intracellular signaling. Well, nitric oxide is a gas; it just diffuses freely across cell membranes and activates certain targets. So it was a new paradigm of signaling in the human body, and that's what warranted a Nobel Prize for its discovery in 1998. But it's a gas; it's produced upon need. Once it's produced, it's gone in less than a second. But during that second it's around, it activates what we call second messenger systems, and it propagates signals in different ways. It affects protein structure and function, and affects hemoglobin delivery of oxygen and enzymatic function, dilates blood vessels. So everything we know about nitric oxide as a signaling molecule propagates these other second messenger signaling molecules that then affect protein structure, cellular function, and even really all aspects of human biology.
Yeah. So for our friends listening, what that means basically is it does everything. Really?
Well, it does things. That's what people have a hard time getting their hands around, because it dilates blood vessels, improves oxygen delivery, it mobilizes stem cells, it prevents our telomeres from shortening. It's how our immune system kill off bacteria, viruses, any pathogen. It's how the neurons in our brain communicate. It's a neurotransmitter. It affects gut motility. It's involved in sexual function in men and women. So the question is, how can one molecule do all these things? And that wasn't known 25 years ago. Today, we have a clear understanding of these mechanism of actions of how nitric oxide signals to affect all those important biological activities. So it's foundational for human health and human optimization.
Yeah. So when you're saying that the mechanism, so they know the exact mechanism on how this gas, so like you said, the old paradigm, which I find really interesting, Nathan, the old paradigm was that lock and key. It talks about like insulin. So there's a key, and you still see some people talking about that today. They say, well, insulin's like a key. It turns on this, it opens the door. And what you're saying is, and I believe the same thing, is that's not how it works. There is no lock and key. So the nitric oxide that's produced in the blood vessels, if it's a gas, only lasts a second. Can you explain to our friends listening, how does that, if it's not a lock and key mechanism, what opens the, I wouldn't say the door, but there's something on the cell membranes called the glycocalyx and all the receptors. So if the nitric oxide attaches to the receptors and on the glycocalyx on the membrane for the different functions of the cell, how does that exactly happen, Nathan?
Well, there's still the lock and key type of cellular signaling, like steroid receptors, or it has to fit into a certain binding site, and insulin receptors have to recognize insulin and then activate those signaling. So that lock and key is still valid. It's just nitric oxide doesn't always abide by those same rules. So nitric oxide is a gas. It's produced in one cell. It can diffuse into neighboring cells. And its primary target was an enzyme called soluble guanylyl cyclase. And without getting too technical, then that enzyme makes a second messenger called cyclic GMP, and that leads to a calcium mobilization, smooth muscle relaxation, and vasodilation. That same activation of SGC affects platelet function, so it prevents platelets from aggregating, prevents blood clots from forming. So that whole signaling cascade has been very well elucidated. So it's just NO binds to a metal, and so it's an electron sharing, right? So nitric oxide is a free radical, it has unpaired electrons. So any redox active metal that is electrophilic, it will take on nitric oxide and then induce a conformational change in that protein or enzyme and change its function. The other thing that it does and how it signals is it binds to cysteine thiols on certain proteins. And it's not really nitric oxide per se, because when nitric oxide reacts with oxygen, can form, nitrite or these other a nitrogen dioxide or nitrosating agents, and they can bind to cysteine thiols. And so that's really some pretty in-depth and technical chemistry and enzymology. But suffice it to say, that's how nitric oxide signals. There's really finite targets that accept nitric oxide. It hits its target and perpetuates and propagates these intracellular signaling cascades. And it's how cells in the body communicate.
Yeah. So summing that up, basically, it's a very complicated process that nitric oxide is a start of it. And then there's downstream effects that signal other molecules to do other things that, basically.
I like to say that if you got a string of dominoes, and once you knock the first domino over, then everything else it's out of the control, right? And so many of these important biological systems, nitric oxide is that first domino, right? You have to activate that in order to get smooth muscle calcium mobilization, activation of SGC and smooth muscle dilation and relaxation, or affecting platelet aggregation, or release of nitric oxide from neurons where it's a retrograde messenger and prevents things like glutamate over excitation and activation of an NMDA receptor. So nitric oxide is that first domino, and you've got to knock over the first domino for everything else to take place. And so without nitric oxide being produced in the body, what we're finding is that's really kind of fundamental cell signaling. So without tipping that first domino, if your body can't make nitric oxide, then anything downstream from that is not going to happen, or it's going to be compromised in its function.
Yeah, that makes sense. So I'm sure our friends listening would love to know what makes nitric oxide and what depletes it. And my guess is it's all the things we've been doing for 100,000 years and in nature, correct? And what we're doing now in our modern society is most likely depleting it. But let's get your thoughts on that.
Yeah, no, look, it's no new science in terms of what all the standard risk factors for disease, whether it's smoking, sedentary diet, processed foods, sugar, all the things that lead to onset and progression of chronic disease all lead to a decrease or an inhibition of nitric oxide production. And then the things that we know from hundreds of years of epidemiological research that extend life, that prevent cardiovascular disease, prevent cancer, all of those things we know now activate or stimulate nitric oxide production. That's what keeps us healthy. So, I mean, it's the science of nitric oxide is very complex and complicated, but the solution to solving a nitric oxide problem is really pretty simple, and it's easy.
Yeah, and I think our friends listening would like that. It's easy. It's how do we say this? It's simple but not easy. So
yeah,
that's probably what I say, because trying to stop eating carbs and sugar and using your phone, and we have these red light glasses on for the screen. There's a lot of things that people need to do that they might forget, or especially the carbs part. Right, eating a lot of carbs, which a lot of people are addicted to carbs, is very difficult to get off. But like you said, that is one of the major things is our diet.
I think it's the thing. Sugar. And I tell people all the time, if you think about sugar, if you spill a soda or just spill a scoop of sugar on the table and you come back the next day, it's sticky. It's like glue. It sticks things together. And so our enzymes and our proteins can't do their job if they're all stuck together. So we have to avoid sugar. And the consumption of carbohydrates and sugar in the American diet over the past 100 years has gone through the roof. And all you have to do is look at the statistics or look at the people around you. We have an epidemic or pandemic of obesity. 9 out of 10 Americans are metabolically dysfunctional. 2 out of 3 Americans have an unsafe elevation in blood pressure. And I think 2 out of 3 Americans are either pre-diabetic or diabetic. I mean, and to me, it's no mystery of why people, it's what they're doing. It's what they're eating. The best way people think that deliver nutrients is, well, let's put them in a gummy or a chew, which is nothing but sugar and seed oils, and let's get your nutrients through gummies and chews. And that's the last thing Americans need, is more sugar and carbohydrates and seed oils that make up gummies and chews. So it's like everything you do in terms of catching on to fads and trying to, these companies trying to bring on new consumers and customers, they entice them with one of the most addictive substances on the face of the earth, which is sugar. And this has to stop. These companies have to be held accountable. And let's get back to the science and what we know works, what reverses, prevents, treats, and cures disease. And it's all lifestyle based. It's not drugs. It's what we do, put on our body, and what we're exposed to. And it's the lifestyle we decide to live.
Yeah, and I really like that, Nathan. In my book, just for our friends listening, I think you're talking about a sugar on a table and it's turned sticky. That's a really good analogy. But what I see in my book, which is going to really help the people listening as well, is that and when I was writing my book, I just kind of thought, hey, this makes sense. I thought, if blood's mostly water. And I thought, well, if you put sugar in water, what happens? It turns into a paste. It gets sticky. It turns into a paste. So I thought, so that's the reason sugar's so bad. And so people talk about insulin, all these things. Insulin's job is not to put, I believe, insulin's job is not to put fat in the fat cells. Insulin's job is to keep the blood flowing. What do I mean by that? I mean that if you eat a lot of sugar, it's thickening out the blood. If the blood gets too thick, it doesn't flow. So I believe the main job of insulin is to keep the blood flowing. That's really what it's about. So when you eat a lot of sugar, as you know, it goes into the fat cells, it gets burned, it gets excreted in your urine. Because the body, I read in my book, it's an emergency. The body has to get rid of it. And so I think that's really important you're saying that, Nathan, for our friends listening, because then they can kind of go, oh, that's why I don't want to eat sugar. Because if you kind of thought about your body, like, imagine your cells and your blood vessels as rivers, they get plugged up, they're not going to work.
Yeah. Well, look, that's what hemoglobin A1C is, right? It's a measure of how much sugar has stuck to your hemoglobin molecule. And it's not just selective. If it's sticking to hemoglobin, it's sticking to other proteins and enzymes. And so it constrains those where they can't, transfer electrons. And that's the basis of biochemistry to develop disease. So you have to eliminate sugar and stop the stickiness occurring in your blood, or else we see the consequences of that, and it's not good.
Yeah, absolutely. And to piggyback off of that, a lot of people don't understand, Nathan, that stress and chronic dehydration, I write this in my book. I made a model of a blueprint for health and disease in my book. People don't understand what stress is not bad in of itself. What stress does is it mobilizes sugar. So stress causes chronic dehydration, chronic stress, not adaptive stress, as you know. But that chronic stress causes chronic dehydration as well as sugar getting mobilized into the blood. So it's not just about eating sugar, it's about everything you're doing in your lifestyle that's stressing you out and possibly causing chronic dehydration. A lot of people, I think that chronic dehydration just means, oh, I'm not drinking enough water. That's not what it means. And you're smiling because that's not what chronic dehydration is. Chronic dehydration is everything we're doing in society. And I'm really happy that when I read your book, you mentioned this Indian doctor's name, Batman Joe. I don't know, what's his name? How you say his name?
That's been 14 years ago when I wrote that book.
It's that Indian doctor who wrote the water cures. Do you remember? Yeah. And
but I can't recall his name.
Yeah, his books are fascinating. And he talks about exactly what we're talking about now. It's chronic dehydration is at the root of everything. So chronic dehydration is causing depletion NO levels, causing stress. So, but it's all a circle, as you know. And so I think that's important for people to understand as well. You had on one of your videos, which we can talk about now, which is fascinating. It was a clickbait and said, bacon will open your blood vessels. I'm like, I eat a lot of bacon. I don't know if you usually go on that, Nathan, probably a lot. But that was fascinating. And I always thought for the longest time since I was a kid, oh, nitrates and nitrites, there's sodium nitrite. And my mom, we can't eat that and this and that. I'm like, okay, I won't eat it. And now we know, as you talk about so eloquently, that this is just absurd. You want to talk more about that?
Those are the headline grabbers. And I'll never forget, I was a young professor of molecular medicine at University of Texas Medical School in Houston. I think it was 2005 or 2006. And we had published a paper showing that the nitrite that's used in cured and processed meats could protect from injury from a heart attack. So you could actually protect the heart from seeing damage if you suffered a heart attack.
Wow.
And then the local news in Houston came to my lab. They did this interview. They go, "You're going to be the headline, the news story on the 5 o'clock evening news today." And so I was like, "Oh, great!" And they go, "I said, just leave the bacon, the hot dog stuff out of it because it creates too much confusion." And they go, "Oh, we're going to focus on the science." So I go home early. My kids are young, and we're in the living room watching TV. And it goes, "A researcher, Dr. Nathan Bryan out of University of Texas Health Science Center, Houston, reveals that bacon can stop a heart attack." Gone. And my phone starts ringing. My department chairs and it's disappearing. You go, "What the shit are you doing?" And I go, "No, it's not me. It's the headline writers." Anyway, they told a very good story, but as you know, headlines are intended to draw people's attention and get them to listen to the bigger story. So, a marketing team does a good job of that and putting these highlights in there to get people to listen to the real story of nitric oxide and grab their attention so we can really kind of unfold all the science around nitric oxide and why people should really be concerned about it. But to answer your question, going back, and this created a lot of controversy in the field when I started in this line of research, because dating back to the 1950s, we were told avoid cured and processed meats that contain nitrite because they form nitrosamines and cause cancer. Well, when we started in this field, we started thinking and kind of looking at the sources of exposure of nitrite and nitrate. And what we found was that 85% of the nitrite and nitrate that we get from our diet comes from green leafy vegetables. And only 5% comes from cured and processed meats. So if nitrite and nitrate cause cancer, vegetarians would have a 10-time higher rate of cancer than carnivores or meat eaters. And we know that's not the case at all. In fact, we published, I believe in 2009, that nitrite actually has anti-cancer properties. So when that kind of accounts for and affords the cardioprotective benefits, the anti-cancer benefits of certain dietary patterns, whether it's the Japanese diet, the Mediterranean diet, the dietary approaches to stop hypertension, all of the hundreds or decades of years of nutritional epidemiology point to the fact that it's the repletion of nitric oxide through all those dietary patterns that can explain the benefits on health and longevity and cardiovascular endpoints and cancer endpoints.
Yeah, and to piggyback off of that as well, you in your book you talk about, I think in one of some of your videos that I've also watched, the nitrites and the nitrates, being a preservative, how it stops, mold growth and bacteria. Well, if you just use your common sense, that's basically what's inside your body. If it's an antibacterial, and it's preserving the meat. I think people have the misunderstanding, the misconception that it was preserving the meat, so it like preserve you. That's not what's happening, right? Like it's not what's happening. It's an actual antibacterial that's keeping the meat fresh. And so if it's antibacterial, that's probably an antibacterial in you as well.
Yeah, well, it's part of it is antibacterial. I mean, it inhibits things like Clostridium and Listeria and a lot of these foodborne pathogens. But I think in terms of a curing, it's preventing lipid oxidation. So when you oxidize lipids, that's when meat gets this rancid kind of nasty flavor. So it's the same thing. We have lipids in our body. Lipids make up our cell membranes, and when they become oxidized, we lose membrane fluidity. So anything that inhibits lipid oxidation is actually a good thing. And that's exactly what nitrite does. So the same curing property, the same chemical properties that we use in curing meat, which is muscle tissue, the same thing happens in our body. It improves blood flow and oxygen delivery. It kills bacteria. It prevents lipid oxidation. It prevents inflammation. And so it's not just on a dead piece of muscle meat, but it's physiologically relevant when it's circulating throughout our entire body.
Yeah, and I like that. I was just thinking about seed oils, and we can talk about, how bad those are with your expression there, and I'm in the same boat with that. But I was thought you were talking about, well, if nitrites prevent rancidity, I was thinking to myself, because, with seed oils, the reason they're so bad is because they oxidize. Obviously, the seed is oxidized once it's opened. They remove the vitamin E, and then all the processing it goes through. I write in my book, it gets, washed. First, it gets pressed with hexane. And are you telling me that there's not hexane? See, I like your expressions. You know exactly what I'm talking about. Hexane it presses the seeds down. And are you telling me all that hexane's removed? I don't think so. It's washed, it's deodorized, all these things. And people wonder if the seed oils are good. I wouldn't think so. But going back to what you were saying about preventing lipid peroxidation, I guess that's not really possible. I thought, well, if they added nitrites to seed oils, but I don't think that would work. I think I'm off in left field a little bit. That's not going to work.
No, in fact, they scavenge any production or any biological activity of nitrite or NO, because you create these nitro fatty acids. So it acts as a scavenger. There's some evidence out there that these can help propagate nitric oxide activity, but if you take them at the same time, the nitrite and the NO basically perform the chemistry on these long chain fatty acids, whether it's oleic or linoleic acid, and basically would scavenge that effect. And then that has a completely different half-life and biological activity than nitrite or NO itself. So it completely changes the metabolic fate of the nitric oxide or the nitrite that we're delivering.
Yeah, and you also talk about, you're saying about scavenging, so you talk about in your book as well, that the too much of a good thing is not good. So the nitric oxide is a free radical. And for our friends listening, free radicals are extremely beneficial, but they can also be problematic. They serve two things. And so too much nitric oxide can react with oxygen, other nitrogen, and create harmful compounds. You want to talk about that?
Yeah, so free radicals and oxygen radicals are toxic, damaging. They oxidize molecules. But the only way to stop a radical reaction is through the introduction of another radical. And that's why nitric oxide is an antioxidant, because it prevents the oxidation of oxygen radicals. So nitric oxide reacts with superoxide radical, rearranges to inorganic nitrite. So basically detoxifies superoxide radical, detoxifies hydroxyl radical. But then when nitric oxide is just floating around, because if you go back to your regular inorganic chemistry classes, there's a polarity between the nitrogen and the oxygen. And so due to that polarity of that bond, nitric oxide likes to donate its electron. And so what we like to say in chemistry is that oxidation is a loss of electrons, and a reduction is a gain of an electron. So any anti-inflammatory molecule will donate an electron, and it reduces, so it provides antioxidant, anti-inflammatory properties. So nitric oxide, yes, it is a free radical, but it's an antioxidant free radical because it donates the electron, affects the potential hydrogen, affects the voltage of the cell, and scavenges any other oxygen radical, and perpetuates this transfer of electron, which is all biochemistry is. It's an electron looking for a home.
Interesting. So nitric oxide is a antioxidant as well. So it's probably one of the most important, well, are we talking about molecules, but most important antioxidants in the body as well?
Well, I mean, if you look at molar concentrations, I think probably the primary kind of buffering antioxidant is going to be your glutathione, kind of your water-soluble antioxidants. There's the vitamin E's, the fat-soluble antioxidants. There's enzymatic antioxidant systems. But the concentration of, say, glutathione is millimolar concentrations in the red cell, and even in circulating in the blood. But if you look at the level of nitric oxide, it's nanomolar or femtomolar, which means 10 to the minus 9 or 10 to the minus 12 molar concentration. So the amount of nitric oxide that's produced compared to glutathione is, orders of magnitude less. So it's potent in the fact that the transfer of the electrons is very fast. It's very fast. It's diffusion limited reaction typically. So it's very effective, but in terms of concentrations, think and we believe it's a very important antioxidant. But again, there's enormous redundancy in the human body, and I think that redundancy is necessary and essential for if you see a lot of oxidative stress, or you're exposed to a lot of oxidants, they get multiple systems coming in to deal with it. And if one's compromised, then you're not going to do well.
Yeah, and so the concentration of the, just to sum up that, the concentration of the nitric oxide is a magnitude smaller than the glutathione and the other antioxidants. And speaking of that, our listening friends, there's a lot of things that are antioxidants, and because we're getting a little technical here, I don't want to lose people. It's getting a little technical, and a lot of people talk about antioxidants being blueberries and berries, and those are, but we make our own as well. But there's also things that people don't even talk about that are antioxidants. One, for one, grounding and earthing is, I believe, and I wrote this in my book, that is the major antioxidant. That's more antioxidant potential than all the blueberries in the world combined. And there's also something called structured water. And I know you know his research, Gerald Pollack and those guys.
Yeah.
Yeah.
And so when you look at, again, it goes back to what is an oxidant and what is a reductant? And it's electrons.
Yes.
And I'm trained as a biochemist, so we have to account for electrons and balance chemical equations, which most people can't do. So we have to have an unlimited source of electrons. And when grounding, the earth is a huge magnet, and it's full of unlimited electrons. So when you walk barefoot on the earth, you're getting electrons throughout the body, and those act as antioxidants. And it's the same. So I completely agree. The biggest source of electrons on this earth is the earth itself. We've gotten away from that. You know, we wear rubber shoes, and basically we have no contact with the earth anymore. Absolutely. So we have to, I go out every day when I get out of my sauna, get out of my pool, and I walk around on the ground, and, you know, I encourage my kids to go barefoot, and, you know, so we've lost that connection. And I think it's really that connection, that lost connection, that's, you know, partly responsible for some of the health consequences we have.
Yeah. And I believe the same thing, Nathan. I think that something as simple as grounding, and it's so, you just take your shoes off, walk outside, it's free. And the other thing that's super important, that is also an antioxidant, is nose breathing. And I read some about this in my book, and you talk about it too in your book. People don't understand the way you breathe is paramount to contributing to all diseases. And when I learned this 3 or 4 years ago, I was mouth breathing my whole life. I had asthma, I had allergies, and I didn't realize how important nose breathing was. Nose breathing is, when you mouth breathe, you cause inflammation, which causes hypoxia, which means less oxygen in the cells. I don't want to go into technical details of it for our listening friends, but basically, just suffice to say, when you mouth breathe, you're causing inflammation. And
you become hypoxic, so you bypass nitric oxide production pathway in the nasal sinus epithelium. The other thing is, when you mouth breathe, you completely change the oral microbiome.
That's right. And
cause oral dysbiosis, because now you're creating an extremely aerobic environment, and that changes the bacteria, changes the biodiversity. It shuts down the nitric oxide producing bacteria. It changes the pH in your mouth and causes complete dysbiosis, which then causes a further suppression of nitric oxide production. So mouth breathing, you know, I just flew back from Stockholm, I guess yesterday, or maybe it was Saturday. I can't remember what date it is. And it's, you know, going there was an overnight flight, and I'm walking, you know, through the cabin, and probably 50% of the people on that plane are just their mouth open, their mouth breathing. And it's going, no wonder we have a sick population. I mean, these people, and they're snoring, they're almost convulsing, and, you know, they're hypoxic, they're not getting good sleep. You know, your body can't heal or repair if you don't get good sleep and you're not fully oxygenated. So it's a huge problem.
It is a huge problem. And you say about that, the snoring and the sleep apnea, all these things. I think people think it's really not inert, but the word is it's really not that important, meaning that, oh, I'm snoring. Some people, it's funny, oh, my husband or my wife snores, or they're mouth breathing at night and they wake up with a dry mouth and all these, but they really don't understand that this causes or contributes. I don't say causes because, there's a lot of factors involved to cause anything, but this contributes to every single chronic condition. So some people are talking about how heart disease and some forms of cancer and diabetes might be caused by mouth breathing and contributed by mouth breathing. But no one talks about something as, out there as maybe multiple sclerosis or Crohn's disease or ulcerative colitis. All these things are contributed to by mouth breathing, because if it causes hypoxia, like you're saying, Nathan, which is causing inflammation, which is causing stress, then it might contribute to it's going to contribute to some form of chronic problem, right?
Exactly right.
Yeah.
Yeah, I think, what I've learned over 30 years in academic medicine and science is that people get sick and get chronic disease for only two reasons. Number one, the body's missing something that it needs, or number two, it's exposed to something that it doesn't need. So if you can allow your body to detoxify the many chemicals and toxins we're exposed to on a given day, and we can replete missing nutrients and now give the body what it needs so the body can do its job, then chronic disease goes away. And so in that paradigm, we're never missing a synthetic compound that inhibits cholesterol production, like a statin. We're never missing some synthetic compound. We just got to give the body what it needs and let the body do its job, and hopefully kind of remediate or mitigate exposure to toxins. And if we can do that, then, I think the body is regenerative by nature. But, the mobilization of stem cells occurs typically at night when we sleep, so we can repair and replace dysfunctional cells. If we're hypoxic, we can't make nitric oxide. Without nitric oxide, stem cells don't get the signal to mobilize. And so we never repair and replace. So this just advances aging, and people have an early demise. People with obstructive sleep apnea have, I think, a 10-time higher rate of heart attack and stroke. They're hypoxic, they make nitric oxide, their blood vessels get inflamed, the plaque ruptures, and that's the end of the story.
Yeah, and I like you're saying, I believe it's just so simple, Nathan. Really, if you really want to get a 30,000-foot view of it, really, this is in rocket science. We were talking, in this podcast, a lot of scientific stuff that might have gone over some of our friends or listening's heads, but just to take a takeaway is, like you said, is you let the body do what it needs to do, and the body is a perfect machine, right? I mean, this has been around for 1 million years. Are you telling me that there's something it can't figure out how to do? I don't think so. It knows how to do everything. And speaking of that, about the body being a perfect machine, we're kind of going off a little topic here, but it's really fascinating. When I was doing my research for my book, I was reading about the ATP or the electron transport chain and different proteins in the body, and how the electron transport chain, which is in the mitochondria, for our listening friends, what it is, it's the thing that makes the power for the cells. The mitochondria makes most of the power for the cells. And so inside the mitochondria, something called electron transport chain. And like Nathan was saying earlier, electrons are the basis of everything. The orderly flow of electrons to our listening friends, remember that. It's the orderly flow of electrons. That is all there really is to it. So on the electron transport chain, there's a flow of electrons, which at the end of the chain basically makes energy. And then there's these pumps in the mitochondria, and one of them at the end that makes what's called ATP looks like a flywheel and actually like a machine. Have you seen some of those videos?
Yeah, I mean, there's all types of modeling, and now through electron microscopy, you can actually visualize this. But
Looks fascinating.
This transfer of electrons creates this electrical gradient across the inner mitochondrial membrane space, and it's that electromotive force that activates the ATP synthase that creates cellular energy. And so you basically convert oxygen to water, and through that process, you create this electrical potential that drives ATP production. But if there's electron leakage, there's a disruption in the electromotive force, and you get decreased ATP production. So that transfer of electrons is critically important, and nitric oxide controls that at complex 1 and even complex 4. So without nitric oxide, You get electron leakage through the electron transport chain. You don't get production of molecular water, cellular water. You get superoxide production. And then the electromotive force is compromised, and so you get less ATP production. So nitric oxide is one of the critical mediators of this entire flow of electrons through the electron transport chain.
Yeah, so it's been like we talked about in the beginning of this conversation. It's basically does everything. I mean, I knew that it was a flow of electrons, and I knew there was some other things in the electron transport chain that mediated that. But also, you got to talk about minerals, vitamins. All these things are part of that are part of these complexes, these protein complexes on the electron transport chain. That without them, sufficient copper, manganese, magnesium, all these things are part of these things, as well as the nitric oxide is maybe the conductor of the whole electron transport chain, which is fascinating. But to piggyback off of that, there is no minerals, or there's a severe depletion of minerals in our food, as you know, and so how people are getting, and that's why you've got local farmers and support local agriculture, regenerative, because minerals don't fall out of the sky. They're in the soil. They're not coming from outer space. And so these things are critical for this functioning to happen, Nathan. And you're correct.
They're supposed to be in the soil. And, there's data now going back to the 1940s. And so from the 1940s to the 2010s, there's been as much as an 80% reduction in basic minerals and nutrients in the soil in American soil. Food grown in America today, you're typically 86% less nutrient dense than the vegetables our grandparents ate in the 1940s. So the foods we eat don't have the necessary minerals and nutrients and vitamins that the human body needs. So we have to supplement. And, even from the NHANES study, 95% of Americans are deficient in iodine. 75% of Americans are deficient in magnesium. Another 70, 80% deficient in selenium, chromium, copper, all these trace minerals that are needed as cofactors for ATP production or normal cellular production or enzymatic activity. So we have to, and I think that's where personalized nutrition comes into play, because where I live and where you live, we may be deficient in certain nutrients based on our diet and the farming practices and the foods we eat. So we have to do micronutrient analysis and figure out what is our individual body missing and supplement based on what you're deficient in. Or, like I think you and I do, we just take humic and fulvic and make some because that provides everything that the human body needs. So it takes the guesswork out.
Yeah. And fulvic and humic I've been studying that for 5 years. I've read as many papers as I can on it. I actually went to, they mine some of these things in northern New Mexico. Right. And in Farmington, I was so excited about fulvic and humic. I actually went to Farmington to, it's not Mother Earth Labs.
Mother Earth Lab.
No, it's not Mother. Is it Mother Earth? I don't know now. But anyway, I went there to see how they do this, and it was fascinating. And I learned about it. It was just, it's what happens for our listening friends is fulvic and humic acid basically contains all the minerals and vitamins and amino acids, all these things that your body needs, because it's made by microbes in soil. And what does that mean? So when the soil is fertile, so what they do is they mine this soil